You're listening to the Subrogation Support Network, a podcast from Madison Wickert and Layer, America's subrogation law firm, with dissemination of new developments and changes in subrogation law, as well as emerging trends and best practices. Here's your host, Ashton Kirsch.
Hello, everybody. This is Ashton Kirsch, your host today on the Subrogation Support Network podcast, sponsored by Madison Wickert and Layer. Today, I am absolutely honored to have one of my good friends and fellow NASP participant. I run into this guy at every NASP conference, and we always, I have a beer. I don't know what Antoine's having, but great guy. It's a pleasure to have him here. Introducing Antoine Rios. How you doing, Antoine?
Yeah, Ashton, thank you for having me here. It's a pleasure. And by the way, I also drink beer.
Beautiful. I don't want to make any assumptions there. So, well, Antoine, I figured this would be an excellent conversation. When we do this podcast, a lot of what we go into is we'll pick a specific topic, something to discuss, talk about. Hopefully the listeners can learn a little bit, but also just have the opportunity for everyone to get to know the participants, right? To get to know you, know a little bit more about Madison Group. Maybe they'll have the opportunity to even work with you in the future. But ultimately, Antoine is one of my favorite experts to work with. I've worked with him for years, his company, the Madison Group, which he'll tell you a little bit more about. But they're just excellent. One thing I always say is when working with experts, it's really seldom where you can find somebody that you actually enjoy having a conversation with, or frankly, who can actually speak. Same with lawyers as well. But ultimately, Antoine is awesome in that regards. Good conversationalist and also amazing at his job, very well versed. So Antoine, and that's enough for me. It's my understanding that Madison Group is really a leader in plastics engineering. What is plastics engineering, and why is your role doing plastics work so important to the insurance industry?
Yeah. Thank you, Ashton. Great question. The Madison Group, a company, we were founded in 1993, and yes, we specialize in plastics engineering. Actually, we have 13 engineers and staff that we only work with, projects related to plastics materials. Now, what is plastics engineering? That's a very broad field that the way I define it is, the field that covers, all the material aspects related to plastic on top of design and manufacturing of the plastic products. Plastics engineering, covers basically all the way from the development of the material, the development of the product, all the way to, maintenance of the product during its lifetime to the time when the product fails and you have a post-mortem type of analysis to figure out why a failure occurred and why the product failed.
Yeah, and a lot of times we bring in Antoine's team, either early in the game to take a look at a failed product, or even later on when we just need a lab, right? A lot of times we'll have mechanical engineers, different folks that are going out there to the scene. There'll be joint scene inspections. And next thing you know, we have to have somebody actually look at the failed component, look at the part. And it's my understanding that, Antoine, you do all of that, right? Your team will go out to the scenes. You guys will just, bring in products to take a look in your lab. Is that kind of in line with what you do?
Yeah, that's correct. We go to the scene. Most of the cases, somebody already has been in the scene. We're not a typical company that will go first to the scene, although sometimes we do it. But that's not necessarily the main work that we do. The main work that we do is, okay, something failed. I look at that product and then figure out why and how it failed, and then sometimes I'm working together with another engineer that has been on the field. And then we try to figure out, okay, if my conclusion is that this failed due to a force being applied in XY direction, together then with the engineer, we try to figure out, well, this is what I see from the analysis perspective. So what in real life does that mean? How did that force in the XY direction was produced? And then how did that lead to the failure that we're looking at?
Right. So typically, let's use an example case, right? We have a water supply line with a plastic fitting. Plastic fitting somehow fails. Next thing you know, leaks causing damage to an apartment unit. So typically that's where client will send out will be an ONC, an origin and cause expert, who may then bring in a mechanical engineer who will go out there to the scene, hopefully do an appropriately noticed joint scene inspection, at which point they'll harvest all the evidence, and then Antoine gets involved. Is that typically how you see it?
Yeah, that's correct. And to extend to your question or original your question before this one, yes, we'll do all that. We'll figure out why the failure occurred, but that also involves, lab work. We had to do material analysis, sometimes to either confirm that a motor failure occurred, but sometimes you're just doing analysis to confirm that something did not happen, because sometimes that's as important to figure out that something didn't happen as of something that really happened. So all that type of analysis is something that we can do here at the Madison Group.
Yeah, give me an example of when you say that something didn't happen. Are you just ruling things out, or what's a good example to kind of show how that works?
Yeah, I mean, definitely ruling things that some people have questions about. For example, I'm going to be talking a lot about pipes, because I end up doing a lot of pipe failure analysis. But we have a pipe that broke and caused this, water damage. And then we want to see, okay, was this created by somebody mishandling the pipe, for example? Is it possible that somebody pinched the pipe or hit the pipe with some type of sharp object and broke it? So that's something that we will do. Okay, let's look at the fractures, and let's look at the pipe under the microscope and see if we can see any type of external trauma caused to the pipe. Or maybe, is it a manufacturing defect? This is a very popular question. There's some type of test that we're going to be figuring out if this is a manufacturing defect or not. I mean, there could be the presence of voids, contamination of the material, things of the sort. Maybe we want to figure out if it was a excessive pressure type of failure or a freezing failure. So all those things, sometimes you still had to do some work to rule those out.
Right, because when you're getting the product, a lot of times the initial scene, they can look at this and say, hey, this is some sort of premature failure, right? This line shouldn't have failed, or this PVC pipe shouldn't have failed. However, it has. And next thing you know, you need to figure out more into it. So that's kind of the next step, is you jump in and try to give opinions as to, hey, from what I'm seeing, without going into this destructively, here's kind of my initial thoughts. And a lot of times, it's my understanding you'll even coordinate or assist counsel in coordinating the joint lab exams, right?
Yeah, that's a joint effort. The coordination, sometimes we host inspections in our lab. So obviously when that happens, a little bit less coordination, but sometimes we need to coordinate with external labs in other places because it's closer to where all the other experts are. It could be that there's a very specific test that I need to perform that I cannot do in-house. So we'll go to that lab that will have that equipment. So yes, usually is a joint effort to coordinate this inspections, because usually there's a lot of parties involved and a lot of calendars to look at, and so it takes a lot of back and forth, and then you have a protocol, and some people have opinions about the protocol. They want to make revisions and all that. So yes, we are involved in the whole process.
Noticing scene inspections, noticing lab exams is probably, it's first off, it's one of the most essential things for counsel and experts to do on any products case. But it's also probably one of the more tedious and frankly obnoxious things that we have to handle, making sure, hey, we have to notice up these 25 different potential defendants. And I'm being relatively facetious with 25. Usually it's, between 5 and 10. Because ultimately my recommendation as counsel is always, it's not just about retaining the evidence, it's about retaining all potentially relevant evidence, right? So, not just the PVC pipe, but also, whatever else near there could have been involved, associated, or in any way tangentially related to the loss. So, it can get interesting, and it also can get interesting with the back and forth of, Now, frankly, on our end, talking to the insured, like, hey, insured, I'm sorry to tell you, but you're going to have to wait another month. We have to appropriately notice this up. And Antoine, I don't know how much you do with that, but insureds have a hard time understanding when we tell them, hey, your business that was generating, $45,000 a month for you, well, it's going to need to stay closed for another 30 days so we can do a subrogation investigation. At which point they Google subrogation. What is that? And the fun begins there. But yeah, joint scene inspections, we could probably do a whole nother podcast just on that, which frankly we probably should. But yeah, that's all fun stuff. And coordinating, experts are busy, right? Antoine, you don't have a bunch of downtime.
No, I don't. And what is interesting, Ashton, is that I could go 2-3 weeks with no inspections, but then all of a sudden, like everybody wants to have an inspection on the same month. It's just crazy. It just goes. I mean, really, I sometimes have 2-3 weeks with nothing about inspections, and then all of a sudden, there are 5 or 6 that I need to schedule. So it's just crazy. It almost feels like everybody gets together and agree, let's have inspections in the month of August, for example. So it can get crazy.
Yeah, and it's not like, experts, it's not like they have families or, play golf or anything like that, travel. I mean, it's 30-day notice and trying to get inspections scheduled can be, the bane of all adjusters and experts and attorneys' existence. So yeah, fun stuff. So whenever I'm frustrated on the phone talking to you, you know why, Antoine. So one other question I had is you mentioned earlier that you have 13 different engineers at Madison Group. Of those engineers, is everyone handling things similar to you, or does everyone have kind of a different area of specialty?
Yeah, actually, well, obviously, the 13 of us work with plastic-related, projects. But we here at a company, we actually do a lot of work with industry. These are non-subrogation-related projects where a lot of the work is in the early development stage, where we are helping clients manufacture their products better. So we work with them on selecting what type of plastic actually they should be using to make this product. How can they design the product better? We can help them in the molding or the actual manufacturing process, how to manufacture the product better. We also get involved, with industry doing failure analysis. There are a lot of sometimes they're doing some internal testing. The product is failing, and then we get called to figure out, okay, what's going on here. And then, we do a lot of the subrogation work with attorneys or insurance companies. So to answer your question, it's 4 of us that handle this type of subrogation legal work. The rest actually work with industrial clients.
Very nice. Okay. Yeah, I don't think I ever asked you that question before. So that's very cool to hear. All right. So now back to subrogation. So I'm sure you deal with a ton of different and unique types of failures, but also many that are probably very similar, toilet lines, couplings, valves, etc. Any major problems or interesting types of failures that you think are worth mentioning or discussing during this podcast?
Well, the one I have right now on the top of my head is the CPVC fire sprinkler failures. You know that because we recently worked with one. So, I mean, that's really one of the major ones right now. And when I say right now, probably in the last 3-4 years, the CPVC plastic piping used for fire sprinklers is a very good pipe, but it's very sensitive to contact with other type of products that could cause issues in the CPVC. So if you lay, which I think is very interesting, you can lay some wires on top of the pipe, and that wire actually over time is going to leach some type of material that is going to affect the CPVC and eventually cause cracking of the CPVC. For example, you can have some fire caulk that is used in the area of the CPVC pipe and lands in the pipe, and this caulk is not compatible with the CPVC, that over time will cause issues. So that's really an area that we have been very busy with Water filters, that's been forever. There are, many different designs of water filters. Water filters can be used as, as simply to filter water into a refrigerator, but it can be used in industrial settings, plants, in manufacturing facilities. Water filters tend to fail usually in the 45th floor of a building, and usually in the penthouse, and then affects 44 floors down. So
Sure does.
this type of failures can be pretty large, but also can be very minor. And that's beyond talking the typical toilet components. But yeah, a lot of things related to piping, either fire sprinkler pipes, but also like, hot water piping, lines, supply lines to refrigerators and so forth.
Agreed. I mean, so the PVC line, the PVC failures, this is something we see a ton of. And obviously there's always a question. Is there a manufacturing issue with the plastics? Is it an installation issue? What is it? A lot of times that's where someone like Antoine can come in and kind of give us a basic opinion. Now, Antoine, tell me a little bit more about it. I just think PVC piping is fascinating because just it's exploded in usage given the ease of installation and the benefits there. But tell me a little bit, and you can, well, frankly, before the podcast, Antoine and I were joking a little bit about, how technical to be with various things for the podcast. And I'm like, well, you can be as technical as you can be with me because frankly, you got to speak to me in layman's terms on a lot of the technical aspects with these things. Getting better though. But ultimately, Antoine, tell me a little bit about the more technical aspects of PVC piping and why it is that we see so many failures with the pipes. Is it just the extent of usage, or is there something just inherent in the manufacture production of these pipes that make them more subject to be it failure or involvement in failures?
Well, Ashton, it really has to do with materials. I think we humans sometimes really need to understand that materials will have its strengths, but it also will have their weaknesses. Going to plastics in general, a lot of times plastics are compared to metals, where plastics will have many advantages over metals, but they also have disadvantages. A plastic material can be easier to shape into a product than a metal. A plastic material can be lighter, for example, but there are going to be some weaknesses of the material that we had to understand. Now, we're talking from plastics now to something very specific as PVC. There are thousands of different types of plastics, and some plastics are going to be better in one application than other. And that's part of the work that actually we do from the industrial perspective is the material selection. So now you go to a material like PVC, and just to specify, there are two types of piping, PVC and CPVC. PVC means polyvinyl chloride, and CPVC is chlorinated polyvinyl chloride. So PVC is mainly used to transport cold water or water at room temperature. CPVC is the material that is typically used to transport cold and hot water for example, in a house or in a building. And also CPVC is that the pipe that is used in sprinkler systems, that typical orange pipe that we were talking about earlier. So PVC is a great material, but it has its weaknesses. And one of the weaknesses of specifically now speaking about CPVC is that it's going to be sensitive to certain type of substances or other products that can be affecting the pipe from the outside in, or sometimes from the inside out. For example, if they cut the pipe and they use a very oily saw and that oil stays inside, that oil itself can affect the pipe over time. So it's a matter of understanding. With CPVC, actually, you can read the manufacturers have a very extensive booklet of what can you do and what you cannot do with the pipe, what it can be exposed to. And obviously, industry is also learning over time. So what happened with CPVC, for example, sprinkler piping, is that there's a company that very early on the construction stage of the building, that's going to lay out this pipe on the on the ceiling to simplify things, or walls. Well, then The guys that do electrical come after that. The guys that then do some of the spraying of the foams or the spraying of the different sealants come in. And sometimes they either something gets lost in translation that they should be using substances that are compatible with CPVC. So they use substances that are not compatible with CPVC and affects it. So it's just a matter of not necessarily seeing as a bad material. It's a very good material, but it has its weaknesses, and it has to be understood by the people that is, using that material. So the person, the architects or whoever is specifying that material in the building has to make sure that everybody else understand that that material is being used, and these other substances have to be compatible with material. So hopefully that makes sense, but because I don't think that there's any good or bad plastic. It's just a matter of what application that plastic is being used for, if that makes sense.
Yeah, it's about intended use and making sure that that's in line with the use that was actually put into play.
Correct.
So, it's my understanding, and similar to what you were just mentioning, that the majority of plastic failures that I see typically in my practice involve some type of chemical or chloride degradation of some sort, a lot of times even caused by municipal tap water or other items. Can you go into a little bit about what chloride degradation is and, how or why this occurs to cause a product to fail?
Yeah, definitely. That's a very typical type motor failure. Actually, CPVC and PVC does not get affected by chlorine. So there's an advantage of that material versus other materials like polyethylene, polypropylene, or acetal, which will be affected by chlorine in one way or the other. But basically what happens with chlorine degradation is, actually, let me take a step back and explain that plastics, and by the way, plastics are also known as polymers. Plastics and polymers are really the same. Rubbers are also a type of polymers, and it's a type of plastic as well. But anyway, polymers, as the word says, polymer, is a material that is made out of many parts. And what that means is that when you have a plastic material, if you really, really, really look into the molecular structure of that material, you will see very, very low molecules that are interconnected. They're intertwined in between each other. So the structure of the plastic, of the material, really depends on all these very low molecules that are intertwined between each other. So what happens now with degradation, in this case, chlorine degradation, is that the chlorine comes and it starts breaking up those molecules. So as you break the molecules, the structure of the plastic suffers. It gets weaker. So this is a process that actually occurs slowly over time. So it's not like you expose it to a chlorinated environment and 2 seconds later you have a failure. No, it will take time. Sometimes it will take weeks. Sometimes it will take months, and other times it will take years to happen. So this chlorine in the water is little by little breaking up those molecules, making them smaller, and then weakening the plastic little by little. And then over time, this weakening leads to the plastic failing under its expected under its expected conditions of use. Temperature, if you have high temperature, that's going to increase the rate at which the degradation occurs. So that's why, as you probably know this, that's why when we see this chlorinated type of related degradation, most of times actually occurs in the hot waters instead of the cold water, because it's accelerated by temperature. If there's a stress or if there's a load or force applied to the product in the specific area, that also is going to accelerate that cracking or that failure. So in essence, degradation due to chlorine is when the chlorine is breaking the molecular structure of the material and then weakening that over time.
And a lot of times I'll be explaining my expert's findings to a client, and I'll explain, hey, some sort of this chemical or a chlorine or chloride material degradation has occurred. This is the basis for the failure. And you can see the clients, or whomever's, the adverse adjuster's eyes just glaze over. It's like, okay, sounds good. So that's you had a really succinct and, clear way of explaining that. So I'm definitely going to refer more and more to my People that ask me questions about what it is to this podcast say, hey, listen to Antoine there. This is fascinating. So
There we go.
when it comes to degradation there, I mean, what type of products are you primarily seeing this in? I know we see this a ton on the toilet water supply lines, right? A lot of times for years, it was actually the metal braided supply lines that had the polymer on the inside, where you'd have some sort of degradation on the exterior, then there'd be material degradation on the actual plastic component. Next thing you know, it would expand and failure occurs. Aside from water supply lines, anything else or any very prevalent, you could say, components or items where you're seeing this?
Yeah, water heaters, components for water heaters, for example, water heater valves. Um, this is exactly the environment we're talking about earlier. They're subjected to a stress or a force, which is the water pressure, but they're also located at the bottom of the water heater because they're used to drain the water heater, right? So they're also subjected to high temperature. And high temperature, we can be talking about 140 degrees Fahrenheit, which is a lot higher than room temperature. So that environment where the valve is working with a high temperature, and then on top of that, you have the chlorinated water, because the water is expected to be chlorinated from your municipal supply, right? The chlorine is used to disinfect the water. And so then that environment there with the water heater valve, temperature and the chlorine from the water really affects this valve. So we see those a lot nowadays. And products used in toilet beyond the plastic supply lines, but you have issues with the components that are inside the toilet tank. Sometimes it's just only because of the municipal water, but sometimes homeowners add chloric tablets into the toilet, and that will accelerate the failures. So sometimes in industrial applications where you have a CPVC pipe carrying a hydrochloric acid, well, the pipe may be okay, but there may be other fittings and other products somewhere in the system that are not resistant to that level of chlorine, like hydrochloric acid. So yeah, there are applications beyond your typical supply line.
Thanks, Antoine. Now, aside from that, any other just in general prevalent causes of failure, aside from just material degradation caused by chemicals, that you often see and that you're asked to investigate and look into for clients?
Yeah, thank you for asking the question, because we are talking a lot about degradation. But yeah, there are beyond degradation, and by the way, degradation can occur with other chemicals besides chlorine, which is another. We can talk probably 10, 20 more minutes about other chemicals that could cause degradation depending on the plastic, right? But there are issues like if we go back to piping systems, either CPVC or polyethylene, whatever the material it is, there could be installation issues. If a pipe is not fixed properly in the on the walls or in the ceilings, there could be some external loadings applied to the pipe. For example, there are pipes that are meant to be flexible, like PEX piping, right? So if you don't support the pipe correctly, it's going to transfer a lot of that stress into fittings that over time are going to fail, because the fittings are not designed to absorb the load from the bending. There should be some type of clamp that absorbs, if you will, that stress from the bending. So you don't want to transfer that stress into the fitting. So there are, installation issues that we see all the time. There's external damage or damage caused like water hammer issues, water freezing. You can have issues from the product if the product is not designed properly, for example. We deal a lot with what we call sharp edges. So these are products that are designed with sharp edges that will tend to concentrate the forces in that edge and create a excessive stress that eventually leads to failure. So there are design issues. Sometimes there are application issues. So if you have a hose that is designed to work at ambient temperature and is used to supply water to a coffee maker or something like that, right? So then that's not the right application of that supply line because it was used improperly. So we had to look at all this. One of the first things that we do, okay, what is the brand? Let's try to find instructions, or let's try to find the specifications of this product to see if it was used in the right application. There are issues with manufacturing like voids sometimes. By the way, not always when there's a void in the product, that's a manufacturing issue. No, there has to be a void, and the void also has to be the place where the crack starts. So,
and Antoine, just to get into the void, I mean, so basically a void would be somehow in the molding or the assembly and the manufacturing of that plastic. There's some sort of, be it, I'll just use the colloquial layman's term, there's air somehow in there, a small little bubble or some sort of void within the plastic. Is that correct?
Yeah, correct. Yeah. Thank you for asking that, because there's like a little bubble in the wall. You have a product, you have a certain type of wall that is containing certain type of pressure where the water is. So if you have a void there and then the crack starts at the void, then you can say, well, the void is really what caused the failure. But a lot of times there are voids that do not really cause the failure. So what I'm trying to do is be specific about the fact that a void does not equal necessarily a manufacturing defect.
And we'll see that a lot on the refrigerator filters, your different filter failures, where we're taking a look, all of a sudden a brand new filter somehow cracks, and question is it pressure? Is it related to there being some sort of material void or issue with the manufacturer or the assembly of this filter? And that's where someone like Antoine can put under microscope. They can do destructive testing to start cutting into it to figure out exactly where that void was, the location of the crack, and then do some sort of failure analysis from that, right?
That's correct, yes.
Beautiful. Any other ones that you wanted to mention before you go on to the next topics?
The other one is it's sometimes confused with chemical degradation, but it's not chemical degradation. It's a different mode of failure, which is called ESC. And this is really what happens with CPVC sprinkler piping. And ESC means environmental stress cracking. And what this is a situation where you have a chemical substance that can penetrate into the plastic, and then that has to be in combination with a stress. When we call it stress is the internal load that is created inside the material due to bending or water pressure. So you have to have a combination of this chemical substance and this stress that will cause softening of the material and over time lead to a crack. So that's even though it's a chemical induced type of failure, is very different than a chemical degradation. So this is very common just because we're talking about CPVC has sprinkler piping. So ESC is one that is worth mentioning. So I am sure there's some others that are out there. I'm not trying to cover everything, but those are the most common that we deal with.
Well, Antoine, let's jump into really a major gripe that I have with insurance carriers in general and different adjusters. And ultimately, most of my clients are great. But this is the one really qualm or issue that I see, and it's the failure to appropriately preserve evidence for future inspections. And a lot of times, sometimes this is an insured's fault, sometimes an adjuster's fault, even sometimes an attorney's fault. But ultimately, without the evidence, and that's all evidence, right? We're not just talking about the product, but maybe it's be it the supply line and the other components, be it a gasket or a connector or something there on that PEX line. But really, without the evidence, we have no case. So, an example would be quite often I'll go to Antoine and I'll say, hey, my client, the insured, threw away everything but the valve, right? There's a failure, water loss. I only have the valve, and all we know is that the valve started leaking. And I'll have to say, hey, can you take a look at this and give me your thoughts? And sometimes there's enough there when there's an obvious failure on the valve, but oftentimes the response is really, hey, we need the supply line or we need more, right? So that's where we tell any clients, anytime there's a failure, consult with counsel, consult with an expert, call myself, call Antoine, call somebody, and just make sure you're keeping everything. Now, Antoine, what advice do you have for these insurance carriers, adjusters, and attorneys as it relates to best practices for evidence preservation?
Yeah, Ashton, that's excellent because sometimes I am sent a half an inch of pipe, and that's sometimes very difficult to work with. But my best advice is try to get more than less. I understand that you cannot get all the piping around the house and send it to me. But if there's, and again, going back to pipes, right? But that's a good example. If you have a pipe with, let's say, a fracture that is 2 inches long, well, maybe cut one foot in one direction, 1 foot in the other. So you're sending me 2 feet of pipe. That is going to make my job a lot easier. It's a lot easier to work with more than less, because what happens is I'm very limited if I only have the section that broke, which is very important. I need to have the section that broke, but I am very limited on how much work on material sampling I can do around that area, because I need to preserve that. But if I have a lot of pipe on one side or the other, I can use that for other type of testing. What also helps is, for example, obviously part of the work that we're doing is identifying the manufacturer of this product. So if, again, going back to pipe, if I get a half an inch or 1 inch piece of pipe, it's very, very unlikely that the manufacturer's name is going to be within that piece of pipe. But if I have 2 feet, 3 feet long section of pipe, it's very likely that, the print of the pipe in that section will tell me, or will help me identify who the manufacturer is. So one advice is try to collect more than less, obviously all within reason. And the other advice that I have is, to make the work the work easier of to make the work of identifying the product much easier is also you can take pictures of the pipe in other areas that may have, the print on the pipe that tells you all this information. That's very helpful. So if the section of pipe that you're sending me does not have that information, let's take pictures somewhere in the ceiling or the wall before it's covered that will show that information, so we can use that to identify the pipe in the future. And the last recommendation, which is very important, is take pictures of where the pipe was located. I understand that a lot of times they go there and the pipe was already taken out of the wall. But if you have a chance to take pictures of the repair, even if the repair pipe is there, take pictures of it, because it's going to help during the investigation to figure out where was it located, what was nearby, what, other components could have created some type of stress or effect on the pipe that may have contributed to this failure. So pictures, quantity, and, information to help me identify the pipe.
Yeah, I mean, there's no excuse anymore for not having appropriate photographs of truthfully anything. Right in my hand is my cell phone, my iPhone, that legitimately is better than, the top photography camera that you could ever buy on the market, 7 years ago, right? We can take videos, we take photographs. Everyone in their pocket has a video camera / professional photography camera. So there's no excuse. So we always encourage our clients, take photos, get your insureds to take photos. When you take that initial statement, ask them to go out there and take photos of everything and anything and preserve sufficient evidence.
Yeah. And, it's interesting because a lot of times I ask for pictures and I get all these pictures about a couch damaged, a very wet carpet. I am sure those pictures are very helpful to some other people. But for me, I need pictures of the actual piece that broke or the component that broke and what's near it. So, pictures of wet couches may be interesting for somebody else, but for me, I need the pictures related to the components.
Yeah, and that kills me. That's about communication between the subrogation team and the frontline adjusters, is that we could have these beautiful photographs, whatever the 8K photos of, a 1970s couch that cost $25 and, these beautiful 200 photos of everything in the house for adjusting the claim, but nobody decided to go and take a photograph of that pipe in the wall that had failed, right? So yeah, always making sure that there's communication. I was encourage all of my client carriers to train their frontline, first party adjusters on subrogation. So at least they know when they need to get their person out there to take those photographs. Now, similar to evidence retention is the issue of the chain of custody. A lot of times we see failure to really comprehend or understand the importance of what it is to maintain an unbroken chain of control and custody for all evidence, especially evidence and equipment and products that fail, similar to those that are sent to Antoine. Now, Antoine, what do you do and how do you recommend clients consider the chain of custody issues, and what can they do better to make sure that the chain is preserved?
Yeah, ideally you want to have this piece of paper called a chain of custody because, obviously it tells you exactly where that product has been from the time it was recovered to, wherever you are in your case, right? But you ideally you want to start that piece of paper sooner than later, and then everybody that touches the product will have to sign on this form. However, that's the ideal situation. However, that doesn't happen all the time. So, typically when we get the product, we're going to have a very good record or who sent the product to us. We're going to have pictures of the label of the, UPS label or FedEx label, whatever way it arrived to us. We're going to have pictures of that. And then after we send it, we're going to keep track of where we're sending that product, or our client is asking us to send it somewhere else. A lot of times we keep it in-house for a few years, and we retain it the whole time through litigation. But a lot of times it has to be sent to another lab or to another party. So we keep track of that. And then usually when we send that product somewhere else, then we are going to start the chain of custody if it was not provided to us with a chain of custody. So yes, the chain of custody is very important to understand, actually to prove where that product has been up to that point.
Right, because the issue is in litigation. When I get that case and we're trying this case and the defense comes forward and somehow argues that the chain wasn't preserved, that, hey, somebody could have manipulated or in some way destroyed, messed with, done destructive testing, or any way you could say in any way messed with that evidence. At that point in time, I'm going to be in a really tough position if I then find out, oh yeah, the evidence sat in the insured's garage for 12 months prior to the case being opened up by the insurance carrier. And we see that all the time. The sad truth is that sometimes we'll even have cases where a client or an insurance carrier says, yeah, we have the evidence. And then next thing you know, we try to send it out to someone for testing. We find out, oh yeah, wait, we have to contact the insured. And well, the insured thinks it's in their garage and they search for it. And they find out, oh, well, actually, it was brought to the trash dump, months ago. So we always tell clients, of course, if you can have some sort of document outlining the chain of custody, beautiful. Most insurance companies either work with third parties or they have evidence lockers and evidence storage rooms on facility. Just make sure that we either have a document that can support where the evidence was from failure to today, or alternatively, have an individual who will be able to opine and in any way testify as to where it was located at that time. So that's huge. Now, also, Antoine, it's my understanding that, obviously you handle non-destructive review and destructive disassembly, as we've discussed, but also that there's more chemicals material testing. Is there, how exactly does chemical makeup and material testing work? And how do you figure out, how a plastic or a polymer is actually chemically made up?
Yeah. When we are involved in these cases, one of the first things that not the first thing, but one of the first tests that you want to do is try to identify what plastic you're dealing with. Remember back when we were discussing where there are thousands of different plastics, some plastics are much better for one application than other. Well, because of that, we need to understand what type of plastic it is. So that's the first type of testing that we're doing to understand the chemical makeup of the plastic. Is it a polyethylene? Is it a polypropylene? Is it a PVC? Is it a CPVC pipe, right? So all these things are really important. Just going to example of PVC, CPVC, I have been involved in cases where PVC pipe was using hot water. Well, PVC is not meant to be using hot water. So if that's the case, and you test the product to be PVC, well, then that pretty quickly you understand where your case is going, right? But now if it's CPVC, then okay, there may be some other issues that may have caused its failure. Sometimes going back to the issue of chemical degradation due to chlorine, if it's a polyethylene or polypropylene material, and when say polyethylene, that involves the PEX, which is PEX stands for cross-linked polyethylene. The X means cross-linked, and PE polyethylene, PEX. And we see a lot of these cases where they are chemically degraded by chlorine. Well, polyethylene, the type of testing that I'm going to do with that material is different than the type of testing I'm going to do with a material like acetal. Even if they are degraded due to chlorine exposure, the testing is different that what I will do in polyethylene and acetal. So that's where things start. Just trying to identify the product. Then once you identify the type of polymer or the type of plastic, once you identify that, then you can determine what other tests you want to do. Chemical degradation, obviously the first test you really do is do a high power or high magnification microscopy inside an SEM, for example, scanning electron microscope, where you can actually visually see the degradation. You can see it. But then there are different tests that you may want to do to confirm the degradation occurred. Let's say you have degradation of the product. You want to test the degradation, for example, through the thickness of the product. Is this degradation coming from the inside out or the outside in? Or it is equally everywhere, right? So that's going to point in different directions. If it's coming from the inside out, okay, well, maybe it was the chlorine in the water. But if it's coming from the outside in, well, it could still be chlorine in the water that was leaking, but it could be another chemical that was in the exterior of the pipe. If it's throughout the whole thickness of the product, well, maybe there are some external issues like temperature that may have played a role. So there are, a lot of information that you can get from doing this type of testing. Was the material properly, when the manufacturer selected that material, did he have the proper additives that were needed for the material to perform during its lifetime? To prevent degradation, you need to add some additives. Were those additives there or not? So yeah, that's kind of where you start getting into trying to analyze the chemical makeup of the material. I mean, those are a few of the examples that I can tell you right now.
Yeah, that's just fascinating stuff. The things that you all can do. I mean, the science behind it it's really interesting what you can find out. No, really, I always like to ask this question. Either ask if I'm interviewing an attorney, I'll ask what's one of the more interesting and unique cases you've handled. On your end, any interesting materials that you've tested or any, fascinating stories or anything worth noting in the podcast?
Yeah, I mean, there are some, let's put it this way. How can I say in a nice way? Products that interact with body parts tend to be interesting, but I cannot probably talk too much about that.
Hey,
but those are products that are inside your body.
You can talk about it, and if for some reason we need to cut it out, we'll cut it out. Go for it.
No, but I can't.
Okay, fair. So,
I mean, there are. I find it very interesting, and I already alluded to this once. CPVC pipes, when they are affected by external, let's say, chemicals, that's very interesting because sometimes it's just the components that you least expected are causing issues in another component. Like, for example, you have the CPVC sprinkler pipe laid out in this building, and then somebody comes, the people that do the communication wiring, which are usually some of the ones that are going to be the last ones in the building, putting this communication wire, network wires, and then some of these wires are in contact with the pipe, and nobody will think about anything until a plastics engineer starts getting involved into it and then starts analyzing the plastic wiring. And that plastic wiring over time, it leaches these other components. Basically, what you add into the plastic wiring is something called a plasticizer to make it flexible. Well, that plasticizer over time comes out of the wiring, and then it gets absorbed by the CPVC pipe if it's in direct contact. And that product then starts, or that chemical, the plasticizer, start penetrating the pipe and weaken it to the point that causes failure. To me, that's fascinating on how, all these products that are completely unrelated eventually are related into a failure. So you cannot ignore anything. So to me, that's fascinating.
That is fascinating. So pretty much what you're saying is, I mean, you have two polymers or two plastics touching each other. So at some point, just from that contact, it's changing. I mean, is it actually changing the chemical makeup of the polymer in a way, or how is that working?
Well, so I was talking about, these wires. We're talking about flexible wire. It's like your garden hose. Is flexible, right? So to make it flexible, you need to add what is called a plasticizer chemical into it. So that really is kind of like a way of lubricating in between the molecules, if you will. So allows the flexibility. But now when that starts coming out of the cable and penetrating the CPVC pipe, what it's doing now is going to make the CPVC pipe flexible in that area. And you don't want that. The CPVC pipe is rigid, supposed to be rigid so it can withstand the pressure, but now the water pressure, right? So now it becomes soft and eventually leads to a crack. So that's kind of like fascinating how the material itself doesn't change, but this plasticizer is getting in between the molecules and making them move and making them soft. So then allows the pressure to crack the plastic.
This is exactly why we work with you, Antoine, because this stuff is this is advanced stuff. I mean, it can get pretty complex and pretty scientific. So I mean, it is really fascinating when it comes to these polymer and plastics failures. So I think we're kind of rounding out the hour. Antoine, do you have anything else, any additional tips, tricks, comments, or anything else that you wanted to discuss before we wrap things up?
No, I think if I'm going to emphasize in something is when I was answering the question about the collection of the evidence is pictures of the site of where the product was located is so important, and sending me enough material so we can do testing with, and then we can identify the product. I think that's very important. A lot of cases are closed. Imagine if it's a manufacturing defect and we don't know who manufactured the product, right? So that's very, very critical.
Absolutely. All right. Well, Antoine, thank you so much for joining us today. It was a fascinating topic. I'm sure we'll be inviting you back in the future. Maybe this was kind of a introduction to the topic. Maybe we can find something more specific to go into at some future point. But ultimately, all of the information provided is fascinating, very useful, impactful for those folks handling subrogation claims and, frankly, claims involving product failures of any kind. So, Antoine, again, thank you so much for joining us today.
Thank you, Ashton, for having me here. And it was my pleasure to talk about plastic failures.
Excellent. Well, you can always find me if you have any questions. Ashton Kirsch, Antoine, I'm sure, would be more than happy to reach out to answer any questions you may have as well. Antoine Rios with the Madison Group. Absolute pleasure again. So that's all we have for today. Thank you, everybody, for listening. Ashton Kirsch signing out with the Subrogation Support Network. Thank you.